Welcome to yet another class, another GRE Quantitative Reasoning class at Examplanet Services. And today we'll be talking about a new topic under the first aspect of the Quantitative Reasoning GRE, that is arithmetic. And the topic we are going to be looking at in this class today is ratio and proportion. Ratio and proportion. All right, so we've been able to run through some of the topics under the arithmetic. That is, we've talked about number properties, we've talked about fractions and decimals, we've talked about sequence, we've talked about real numbers, and so on. So if you missed those classes, you can quickly go through those videos and then see this one later. Okay, so now let's move on to today's class, ratio and proportion. Now under this topic, we'll be looking at ratio, we'll talk about total ratio, we'll talk about proportion, and we'll also talk about direct proportion and indirect proportion. All right, so if you are ready, get your writing materials and let's get started. Okay, now what is a ratio? A ratio is used to compare the sizes of two or more quantities. Simple. So that's what we use the ratio for, just to compare the sizes of two or more quantities. Now the values of the quantities must be in the same unit. The values of the quantities must be in the same unit. Note that. So when you're comparing two values or quantities, you have to make sure that they are in the same unit. And what do I mean by that? For example, let me say we want to compare 50 cents and $2. All right, 50 cents and $2. Now here it is wrong for me to say this is 50 ratio 2, or maybe when I simplify it I have 25 ratio 1, that's variable size by 2. This is wrong. And why? Is because these two quantities, they are not in the same unit. This is cents and this is dollar. Even though the two are, they are currencies of the same country, but at that, these quantities are not in the same unit. So it is either we change this to dollars or we change this to cents, so that they will be in the same unit. Okay, so to make it easier, I can decide to make this one, turn it to $1. And note that 100 cents is $1. Therefore, 50 cents must be what? Half $1. Okay, so now it means what I simply have is half $1 ratio to $1. $2. Okay, so now I can express this in a simple ratio, like the ratio value should be integers. And what can I do? Let me show you something here. Half ratio 2 is the same as half divided by 2. Yeah, okay, so which is the same thing as half times 1 over 2. And that gives us 1 over 4, or 1 ratio 4. Okay, so it means 50 cents to $2 is 1 to 4 in ratio. So it simply means $2 is 4 times 50 cents. That's what that means. So they're all simply saying we have 4 of 50 cents in $2. 4 of 50 cents in $2. Okay, so the two quantities must be in the same unit. And you can also change maybe your $2 to cents. So I will have 50 cents ratio $2 in cents to be what? 200 cents. So divide both sides by the smallest or their common factor, a number that I can divide it to. That will give 1 ratio 4. The same way. So you get the same answer there. So that's what we are talking about. The two quantities must be of the same unit. Okay. Now moving on. So 2 ratio 3 is equal to 2 over 3, and that's 0.67, just like what I just showed you there. All right, so we express our ratio in fractions. So 2 ratio 3 is same thing as 2 divided by 3. And in decimal, that's 0.67. Okay, 5 ratio 2 is same thing as 5 over 2. which is equal to 2.5 in decimal. So you can always turn your ratio to fractions in order to simplify it. Alright, so hence if x over y is equal to 1 over 2, or x ratio y is equal to 1 ratio 2, this does not necessarily imply x is equal to 1 or y is equal to 2. X could be 10, y could be 20. Ratio x to y will still be 1 over 2. Now, what I want to talk about here, you need to understand when you see a ratio and interpret correctly. Okay, so if you see x over y, this is the same thing as x ratio y. So it's equal to 1 over 2 means it's equal to 1 ratio 2. So here what we are having is a ratio. Most times in GRE, they may not write it in ratio form like this. They write it in fraction. And when you see this, this does not imply that your x is equal to 1 and y is equal to 2. No, it is not necessary. Though it could be x is 1 and y is 2, yes, but it might not be as well. Okay, so you have to understand when you see a statement like this. So for example, you may see something like this in GRE, when they will tell you a over b is equal to 2 over 5. And you can say quantity A, you have B minus A, quantity B, and you have 3. Okay? So when you see something like this, what do you think? Okay, from what you are seeing here, you want to say, yeah, it means it's equal to 2 and B is equal to 5. So if I find B minus 2, B minus A, that is equal to 5 minus 2, and that will be 3. So definitely B minus A is equal to 3. The two quantities are equal. But I can tell you, you are completely wrong. And why? It's because this thing you are seeing here is simply a ratio. So it means any two numbers you can have like this, like if you simplify them, you get 2 over 5, can represent your A and B. So for instance, imagine if my A is 4 and B is 10. Okay? So if I do A over B, I have 4 over 10. Which when I break it down by each number by 2, I get 2 over 5. Oh, so what if I have my A to be, let's say, 10 and my B to be 25? So meaning A over B will be 10 over 25 by 5 by 5, I have 2 over 5. So what does that mean? It means if I have this statement here and I want to find B minus A, my B minus A could be 5 minus 2, which is going to be 3. My B minus A could be, according to what I have here, 10 minus 4, which will be 6. My B minus A could be, according to what I have here, okay, 25 minus 10, which is what? Which is 15. So which means my B minus A can be any number. It may not be 3, it can be greater than 3. So it simply means here, we cannot determine this. The answer is D and not C. So it's simply a ratio that we are having. It simply means a ratio B is 2 ratio 5. That's what they're telling us. It's a ratio. So it simply means the values have been divided by a constant to produce this 2 and this 5. And you don't know that constant. You don't know that constant. So definitely, you cannot really say what the exact value of A and the exact value of B will be. Alright, so that is exactly what you need to understand here. So in this kind of question, D is the answer. You cannot say maybe minus A is equal to 3. No, because your A could be any number as long as it's a multiple of 2, and your B could be any number as long as it's a multiple of 5. Alright, and you can divide them, 2 of them, and you get 2 over 5. Okay, so just take note of that. That's what we're saying in that point there. Therefore, for example, if the ratio of the number of boys to the number of girls in a class is ratio 4, then the number of boys in the class must be a multiple of 3. That is 3, 6, 9, 12, 15, and so on. While the number of girls must be a multiple of 4. That is 4, 8, 12, 16, 20, and so on. Also, since the total ratio is 7, that is 3 plus 4, then the total number of students in the class must be a multiple of 7. That is 7, 14, 21, 28, 20, 35, and so on. Hence, if the number of boys in the class is 15, that's 3 times 5. Then the number of girls in the class is 20, that's 4 times 5. And the number of students in the class is 35, that is 7 times 5. Okay, so what we're talking about here is if you're looking at this information here, ratio of number of boys to girls, 3 to 4. Alright, means ratio of the boys, 3, that of girls to 4. Okay, so what this is saying, since the number of students must be an integer, a whole number. So it depends on what they are talking about. They can talk number of people, number of balls, number of oranges, number of, and so on like that. So those things that you know that the value, the number must be an integer, a whole number. Now it means that if we are saying boys ratio girls is 3 to 4. So what this means is that the number of boys in the class must be a multiple of 3. Yeah, multiple of 3. So, and the number of girls must be a multiple of 4. Hence, boys could be, say, 3, could be 6, 9, 12, and so on. Multiples of 3, that's numbers 3 can divide evenly. Alright? While the girls could be 4, 8, 12, 16, and so on. That's multiples of 4, their ratio. Okay? So, that is exactly what we're talking about here. So, the point is, now, if the boys are, let's say, 12, then the girls must be 16. Yes, because if boys are 12, that is their ratio, the 3, their ratio, times 4. Then the girls also must be their ratio times 4. So what happens to the boys must happen to the girls. So meaning if boys are 12, girls must be 16. Yes. Then the total ratio, which we'll still look at later, is the sum of their ratios 3 plus 4, which will give us 7. So it means total number of students in the class, total number of students must also be a multiple of 7. That's total ratio, 7. Must be a multiple of 7. So if boys are 12, that's their ratio times 4. And the girls are 16, that's their ratio times 4. Then total number of students must also be the total ratio times 4, which will be 28. And if you sum 12 and 16, what do you get? 28. Okay, so whatever is happening to the ratio of boys must be happening to the ratio of girls and must be happening to the total ratio. So if you are dividing each of them by a number, you are dividing the rest by the same number. If you are multiplying one of them by a number, you are multiplying every other one also by the same number. Okay, so that's one thing you have to understand about ratio and how you interpret it and how you apply it to solve your problems quickly. Alright, so now we have total ratio. So if the values of two or more quantities are expressed in ratio, then total ratio represents the total value of the quantities. Yes, if we have two or more quantities that are expressed in ratio, that's the values of two or more quantities expressed in ratio, then total ratio represents the total value of the quantities, of the two quantities. Okay, just like I showed in the last example. So if we add the ratio together, we have the total ratio. Now we have a simple example here. It says John and James are to share 50 oranges in the ratio 2 to 3 respectively. How many oranges does each person get? How many oranges does each person get? So they are sharing 50 oranges in the ratio 2 to 3. John and James. Alright, so we have John ratio James equals to ratio 3. And they are sharing a total of 50 oranges. So how many oranges does each person get? So for John, the ratio is 2. But first we need to do is to find the total ratio, since we have total number of oranges they are sharing. Alright, so total ratio will be 2 plus 3, which will give us 5. So it means John is getting, you can see John for 2, James for 3. So John is getting 2 out of 5 of 50 oranges. 2 out of 5 of 50 oranges. That's 2 to 5 of 50 oranges. So 5 here, 1 here, 10. And that means John will get 20 oranges. And James will be getting 3 out of 5 of 50 oranges. So here we have 10, and that gives us 30 oranges. So John gets 20 oranges, James gets 30 oranges. And if you look at it, John ratio James, which is 20 ratio 30. If we divide each of them by a common factor, which is 10, what do we have? 2 ratio 3. So which gives us our ratio back. Okay, as you can see, so that means these values of their oranges have been divided by 10 to actually produce this ratio. That is why whatever happens to this 2 must happen to the 3, because we will definitely, if we multiply 2 by 10, we must multiply 3 by 10. And we must multiply total ratio by 10 to produce the 50 oranges. Okay, for instance, you can have an example like this. John and James shared their total weekly wage in ratio 3 to 4. If John got $27, how much was their total weekly wage? Can I see that? So John and James shared their total weekly wage in ratio 3 to 4. So if John got $27, how much was their total weekly wage? So here we have John ratio James to give us 3 to 4. Now, since we're talking about total weekly wage, I will find total ratio. Total ratio will be 3 plus 4, which will be 7. Now, if you look at how much John got $27. And that $27 means John's ratio times what? Times 9. Times 9. So it means the ratio of John times 9 gave the amount for John, or the value for John. Therefore, it means the total weekly wage, alright, total weekly wage will also be the total ratio, which is 7 times 9, definitely, because whatever is happening to this must happen to this and must happen to total ratio. And that means they share the total of what? $63. Yes, that's total weekly wage. Simple, as simple as that. That's not need to stress yourself. So now you may want to check, okay, what about James? Probably what of if question asking about James? That means James too, since John got $27, that's times 9 of his ratio. Then James also must be, his ratio is 4 times 9, and that will be what? $36. Now you can add $36 and $27. What do you get? You get $63. Okay, so that is simply how we can apply that to get our question solved easily. Let's move on. So note, always try to express ratios as fractions when calculating. Alright, so turn your ratios to fractions when you want to calculate. It makes it easier. Now we have proportion. Now this is a statement of two equal ratios. Okay, two equal ratios. Now don't let's waste time. Let me just go straight to types of proportion that I can understand better what we are talking about here. Now we have first one, which is a direct proportion. Now this is a proportion in which the two quantities involved change in the same direction. That is, when one quantity increases, the other also increases, and when one decreases, the other also decreases. Okay, so we are talking about two quantities here. So how the change in one affects the other. So if you increase one, it also causes an increase in the other, and if you decrease one, it also causes a decrease in the other. So that's what I mean by a direct proportion. A direct proportion. Like for instance, if you imagine that you will feed 20 people with 50 oranges, right? 20 people will require 50 oranges. Now imagine if you have to increase people to 30, and they probably take orange the same way, at the same rate. So we do need more than 50 or less than 50? it's obvious you're going to need more oranges than 50. So if you increase the number of people, you have to increase the number of your oranges that you supply. So that is what we call a direct proportion. So increase in the number of people will cause increase in the number of oranges you need to supply. And if you reduce the number of people, you also have to reduce the number of oranges you supply. So that is simply what we mean by a direct proportion. Increase in one causes an increase in the other, or decrease in one causes a decrease in the other. Okay, so let's look at a simple example there. So this example says a car uses 4 liters of diesel to cover a 100 kilometer distance. Now, how many liters of diesel will be needed by the car to cover a distance of 150 kilometers if it moves at a constant rate? Okay, 4 liters will be needed to cover 100 kilometers. How many liters will be needed to cover 150 kilometers? I say that. So if you need 4 liters to cover 100 kilometers, now you now need to increase your distance from 100 to 150. So do you need more fuel or not? Yes, that means you have to increase your liters, number of liters of fuel or diesel that you're going to use as well. So that shows increase in the distance will cause increase in the liters of fuel that you need. And that means you have a direct proportion. So now, under direct proportion, what we do is we cross multiply. So if the first quantity is giving rise to the second, then the change also having this, then we'll cross multiply the two. So this multiplies this because this multiplies this. Alright, so let's say we do that in this example here. 100 kilometers will require 4 liters. Now, how many liters will cover 150 kilometers? So since we'll be able to confirm it's a direct proportion, because as we increase the distance from 100 to 150, we have to increase the number of liters of fuel that we need. Then we have to do a cross multiplication. So it means, let's say this one is a L liters. Okay, so that means you're going to have 100 times L will be equal to 4 times 150, or 100 L is 600. Both sides by 100, then L will be 6. That means we need 6 liters to cover 150 kilometers. Yeah, 6 liters to cover 150 kilometers. So that is what we need to understand here. Okay, now let's look at the next one, which is indirect proportion. Now this is a proportion in which the two quantities involved change in opposite directions. That is, when one quantity increases, the other decreases. Simple. So an increase in one will cause a decrease in the other, or a decrease in one will cause an increase in the other one. So the change in opposite directions, not the same direction, opposite direction. When one increases, the other one decreases. When one decreases, the other one increases. Okay, so you can see here now, if this gives rise to this and this gives rise to this, now under indirect proportion, what we do is a direct multiplication. We don't cross multiply, we do a direct multiplication under indirect. While under direct, we do a cross multiplication. But under indirect proportion, we do a direct multiplication. So x1 times y1 will be equal to x2 times y2. So let's look at an example here. If you look at it, it says 10 painters working together at their respective constant rate can paint a building in 20 days. How many days will it take 8 painters working together at the same constant rate to paint the same building? Now, let's look at the question, because in GRE, they will never tell you if your proportion question is direct or indirect. No, they can never mention it. So when they give you the question, you have to think about it by yourself. Try to digest it, try to imagine it, and then see, okay, if this one increases like this, will it cause an increase in this one or decrease in the other one? So that we're able to know if you're having a direct or indirect. You have to know first before you can answer the question. Now let's look at this. Let's talk about 10 painters and we paint a building in 20 days. Now you now want to reduce the number of painters from 10 to 8. Okay, so now when you have 10, you are spending 20 days. By the time you now have 8 painters, what does that tell you? It simply means you're going to spend more than 20 days, because you are reducing the number of workers. Alright, and the job is not reducing, the job is still the same amount. Definitely you will need to spend more days to complete your task. So reducing the number of painters from 10 to 8 means the number of days will have to increase. They will have to add more days. So definitely decrease in the number of painters will cause an increase in the number of days or the duration of the project. Therefore, we are having an indirect proportion. Increase in one causes a decrease in the other, and decrease in one causes an increase in the other. Alright, so let's go look at the solution to this. So how many days will it take 8 painters working together at the same rate to paint the same building? Alright, so let's look at the solution. So 10 painters will require 20 days. Now 8 painters will require how many days? So let's say D days. So like I said, under indirect, we don't cross multiply, we do a direct multiplication. So it means 8 times D must be equal to 10 times 20. Okay, and that means 8D is equal to 200. Both sides by 8. Then D will give us what? 25. So meaning we need 25 days for 8 painters. So decreasing the number of painters will cause an increase in the number of days. Alright, so that is how we can solve indirect proportion questions. Okay, now let's look at these questions quickly to wrap up the class. Alright, so number 1, the ratio of 1/3 to 3/8 is equal to the ratio of what here? Okay, ratio of 1/3 to 3/8 is equal to the ratio of, so if you remember from the example I did the other time, so you can try this now. Alright, so they want to express this ratio instead of in fractions, you want them to be in integers. Alright, so 1/3 ratio 3/8, that's what the question is asking you. So it's equal to the ratio of what among these options? So let's see the solution to this. Alright, so 1/3 ratio 3/8, and like I told you, you can always write your ratio as a fraction. So 1/3 divided by 3/8, that's what we have here. And from our fraction, that means 1/3 times 8/3. So what does this mean? 8/9, or which means 8/9. That's it. So 1/3 ratio 3/8 is the same thing as 8/9. And that would be option what? Option D. Alright, option D, 8 to 9. Okay, so to number 2, it says at company Y, the ratio of the number of female employees to the number of male employees is 3 to 2. If there are 150 female employees at the company, how many male employees are there at the company? Okay, so simply like the example we did the other time about John and James sharing their weekly wage. So same thing here. So ratio of number of female to the number of male employees is 3 to 2. So if there are female employees at the company, how many male employees are there at the company? So I may not bother myself with this. I can give it to you to try and solve, but let me just explain. So now the ratio of female to male, 3 to 2. Alright, so female to male, 3 to 2. That means ratio of female 3, ratio of males 2. And you have 150 females. 150 females. What does that tell you? That means the ratio of females times 50, that's 3 times 50, has given us 150 females. So automatically, that means the number of males will also be the ratio of males times 50, which means 2 times 50, and the answer must be 100. As simple as that. So you don't even need to hold your pen to calculate anything here. 5 seconds, you pick your answer and you move on. Alright, so if the number of female is 150, the number of males must be 100. So the ratio will be 3 to 2. Okay, that's the solution to that. Next one, number 3. Each of the flowers in the vase was either red or blue or white in color. The ratio of the number of red flowers to the number of blue flowers to the number of white flowers in the vase was 7 to 5 to 2 respectively. If there are more than 5 white flowers and less than 25 red flowers in the vase, what was the number of flowers in the vase? Okay, so we're having a good question here, a good question. Okay, now how can we answer this question? Alright, now just we'll take it step by step. Just follow me. It's a simple question to do. Alright, now let's check out the solution. Okay, So the question says the number of red, ratio of red to blue to white is 7 to 5 to 2. So what does that mean? The ratio of red 7, that of blue 5, that of white 2. And first thing you have to remember here, just like I explained, you're talking about flowers, so you cannot have 2.5 flowers, 3.5 flowers. So the number of these flowers must be integers, whole numbers. So it means the red flowers must be multiple of 7, the number of red flowers. Yes, like maybe 7, 14, 21, and so on. The number of blue flowers must be a multiple of what? 5. That's maybe 5, 10, 15, and so on. And the number of white flowers must be a multiple of 2. That's 2, 4, 6, and so on. Okay, so now, once you have this at the back of your mind, it makes it work easier. Now, look at the information here. You can see that we have more than 5 white flowers. More than 5 white flowers. What does that mean? It means the minimum number of white flowers will be what? Will be 6. More than 5. And we must have multiples of 2. So the least multiple of 2 that is more than 5 is 6. So minimum number of W must be 6. Okay, now other information is a red flower. We have less than 25 red flowers. Less than 25 red flowers. And if you have less than 25 red flowers, what does that mean? It means that from our red flowers, as you can see, red must be multiple of 7, 7, 14, 21. Then it means the maximum number of red flowers must be 21. Okay? Yes, 21. Because it must be less than 25. And must be a multiple of 7. So it must be maximum of 21. So now it means this white, as you can see here, must be a minimum of 6. So if you say, what of 8? If it is 8, that's times 4. That means the red must be times 4 as well, which is 28. But I've told us that the red must be less than 25. That means 20 is not possible. So red must be 21. Okay? You can also say that from red, okay, since maximum is 21, what if we say 14 is possible? If it is 14, that is times 2. That's the ratio, which is 7 times 2. In that case, it means white must also be the ratio times 2, which will be 4. But I've told us that the white must be more than 5, so it cannot be 4. So what does that simply tell us? This simply means that our white flowers are 6 in number, and our red flowers are 21. So that's the ratio of white times 3, which will give us 6. The ratio of red times 3, which will give us 21. And therefore, that means also that blue does not have a choice. It also has to be the ratio times 3, which will give us 15. So that means total number of our flowers will be equal to 6 plus 21 plus 15. And when you add that, what does that give us? It gives us 42 flowers in total in the vase. Okay? Yeah, I know it's a little technical. Just go through it again. It's as simple as that. First, know the multiples of the number of each flower, and then see how you can use the information white must be more than 5, red must be less than 25 to answer the problem, to know the exact values of the number of flowers for each color. Alright, so E will be our right answer, 42. Okay, now on to the next question. Now next question says that the ratio of the number of students in class 1 to the number of students in class 2 is 3 to 4. The ratio of the number of students in class 1 to the number of students in class 3 is 2 to 3. Which of the following could be the total number of students in the 3 classes? Okay, the 3 classes. Now, let's check out this. Alright, so the question says, ratio of class 1 to class 2 is 3 to 4. and ratio of class 1 to class 3 is 2 to 3. So what's the possible number of students in the three classes? Now, if we check this, you can see that we have class 1 and the ratio is 3 here. The same class 1 here, the ratio is 2. So we're having the same class, which is having two different ratios here. And why is because we are comparing that class with two different quantities, class 2 and class 3. So that's why we are having different ratios. So first thing we need to do here is to make the ratio of class 1 the same. These two numbers to be the same in the ratio first. So that's first thing you need to do. And to do that, what can we do? We multiply this one by this 2 and multiply this 2 by this 3. And whatever we do to this, we must do to this, remember? Whatever we do to this, we must do to this. So this means we are multiplying this here by 2 and multiplying this by 3. Okay, so it simply gives us this class 1 ratio class 2 to now be equal to 6 ratio 8, and class 1 ratio class 3 will now be equal to 6 ratio 9. Okay, as you can see here now, the ratio of class 1 is now the same in the two ratios. So now we can combine these three classes as single ratio. That will give us 1 ratio 2 ratio 3, and that will now be what? 6 ratio 8 ratio 9. Okay, so what does that mean? The ratio of class 1 is 6 to 8 2 to 3 9. So this is when we can now think about their numbers. As they are here like this, we couldn't do anything because we have to put them together first. Now we can be sure that the number of students in class 1 must be a multiple of 6. Number of students in class 2 must be a multiple of 8. And number of students in class 3 must be a multiple of 9. So what does this mean? This means total ratio, since you are looking at total number of students possible. So the total ratio will be 6 plus 8 plus 9. And when you add this together, what do you have? 6 plus 8 is 14, and 14 plus 9 will give you 23. Okay, so this means that the total number of students in the class, alright, total number of students in the three classes must be a multiple, alright, let me manage here, multiple of 23. Multiple of 23. So which is, that is, could be 23 or maybe 46, alright, and so on like that. You can add more, just keep adding 3, and the other one is 69, and so on. So all we need to do is to check our options. Which of these numbers, a multiple of 23, is among the options? So which one will be our answer? Let's check. Alright, so obviously option E will be the right answer. That's the only multiple of 23 we have here, 46. So E is the correct answer. Okay. Alright, let's move on to the next one. Now number 5. The question says, for 5 hours, a photocopier copied at a constant rate of 2 pages every 3 seconds. For 5 hours, a photocopier copied at a constant rate of 2 pages every 3 seconds. Now, quantity A, the number of pages the photocopier copied in 5 hours. And B, 12,000. Okay, so you can just use the idea of a proportion to answer this kind of question. Okay, so the copier will produce 2 pages every 3 seconds. 2 pages require 3 seconds. Now, we are looking at the number of pages that will be done in 5 hours. So if you can do 2 pages in 3 seconds, now how many pages are you going to do in 5 hours? 3 seconds to 5 hours. That means you have increased the amount of time. So definitely you expect to produce more pages than 2. So an increase in the period of time will also cause an increase in the number of pages that will be produced, and that is simply a direct proportion. Proportion. Okay, so that's what I have here. So now let's see the solution to this. Alright, so now 2 pages to be done in 3 seconds, then P pages in 5 hours. So what's our P compared to 12,000? So first thing we need to do here is 5 hours. This is seconds. Don't forget that proportion is simply a statement of two equal ratios. So it's still about ratio. And the idea is that we can see that seconds and hours are not the same unit. So we have to make sure that these two are in the same unit now, pages. But here we are having two different units, seconds here, hours here. So we have to first change this one to seconds as well before we can solve the problem. Alright, and don't forget 5 hours to convert to minutes, that's times 60 minutes. And then to now convert to seconds, that's times 60 seconds. So it gives you 5 times 60 times 60 in seconds. So let's just leave it like that. I don't need to waste our time to multiply this out. So it means 2 pages will be 3 seconds. And now P pages will be 5 times 60 times 60 seconds. Now, in direct proportion, what do? You cross multiply. So it means P times 3, that will be 3P, is equal to 2 times 5 times 60 times 60. Now my P will be 2 times 5 times 60 times 60 divided by 3. So 3 here, 1, and here 20. So this is 2 times 5, 10. So that is 10 times 60 times 20. Alright, what can I do? I can just say 6 times 2. That will give me 12. And then 1, 2, 3 zeros. Add them there. So that means I'm going to produce 12,000 pages when I do it in 5 hours. And it is the same as my quantity B, as you can see. So that means my answer will be C. The two quantities are equal. Alright, the quantities are equal. So that is the simple idea with that. Alright, so now the last question here says a desert outpost has a water supply that is sufficient to last 21 days for 15 people. At the same average rate of water consumption per person, how many days would the water supply last for 9 people? Okay, so a desert outpost has a water supply that is sufficient to last 21 days for 15 people. So at the same average rate of water consumption per person, how many days will the water supply last for 9 people? So we have to look at this. This is pure proportion question. But let's look at what they're saying. Now, we have 15 people that will consume an amount of water for 21 days. Now, the question is asking us that at the same rate of water consumption per person, how many days will the water last 9 people? So you have 2 people and the thing will last 21 days. If you now reduce the number of people to 9, now the number of days that we use to consume the water, will it be less or more than 21? So if 15 people could use it for 21 days and you're now having 9 people, you're reducing the number of people. So definitely automatically they will use it for more than 21 days. It means reducing this 15 to 9 will cause an increase in these 21 days. So it will last more. So it simply means you're having an indirect proportion. Indirect proportion. Okay, indirect proportion. So it simply means 15 people will finish the water in 21 days. Now 9 people will finish it in how many days? Let's say D days. Okay, so like I said, if you reduce the number of people now to 9, then you expect that the number of days will definitely be increasing. It will increase. So this means we have an indirect proportion. And when you have an indirect proportion, what do? You do a direct multiplication. A direct multiplication. So that means you're going to be having 9D to be equal to 15 times 21. 9D is equal to 15 times 21. Okay, and therefore that means D will be 15 times 21 all over 9. Alright, like I always say, don't bother yourself multiplying out first. Just leave it like that. You may see something that will cancel it out when you are dividing. So that to save your time, don't just rush to calculator and you press calculator all the time. So 3 here, you have 3. And 3 in 15, you have 5. I can see 3 here again, 1. And in 21, I have 7. And that means my D will be 5 times 7. And therefore, I have 35 days. It means 9 people will finish the water in 35 days. 35 days. Okay, so that is how we can get that solution done. And what option will our answer be? So that's definitely option C. Option C will be our correct answer, 35 days. Alright, so that is how we handle questions on ratio and proportion. And with that, we've come to the end of today's class. I want to believe you've learned and understood everything about ratio and proportion. Okay, so like I always say, I would advise you go through the video again, look at those questions again, look at their solutions. You can try the questions by yourself again and then look for more questions to solve, and that gets you better. All right, so and in the next class we'll be wrapping up on the first aspect of the GRE quantitative reasoning, that is, it remains just percent that we'll be talking about, and we'll wrap up on arithmetic before we move on to the next aspect, which is algebra. So ensure you don't miss that class. So see you then. Bye.